I'm going to start here, right? Let's shrink it to a length of 1. Throw the 8 up there in the numerator. Right up there, right up with that. Where that 1 was. Let's try. All right, what's that magnitude? I'm just going off the side here to do the math like you said. Let's find that magnitude. What's negative 2 squared?
4.
The best thing is these always come out positive, don't they?
9.
No matter what. 3 squared?
Root 29.
29? It's going to be an ugly looking answer then. And when you're telling me divide out a root 29 in front of this vector, negative 2, 3, 4. Now right now, I'm going to put a 1 here, but I'm going to erase the 1. That's a unit vector, right? That has length 1. We need one with a length of 8. What do we do?
Multiply by 8.
Done.
That's an accept, we don't need to.
Oh my gosh.
or anything, we make
Like
it
a
real
test,
quick.
I want to be clear about it. That is totally acceptable. But, and did you notice that practice set, some of these were multiple choice, so you might have to what?
Should work.
Yeah, show work, that's great. I want to see, I love when you show work. I love that. I love that, but you might have to match it up where someone rationalized the denominator or if they distributed it. Does that make sense? So you'd be like, I know this is hard. Which one of these is that distributed? Cool. But yeah, that's it. You go, he says I can stop there. I don't have to write 8 squared root 29 over 29. Isn't that good busier? You can distribute it, negative 16 over root 29, etc., but that's fine. The key is you know how to do this. All right. Hey, what else in 12.2? We got to go back to that adding of vectors. And when we said that we want to add vectors together, we got to add, you said, you kept it simple. To add the x's and add the what?
Y's.
Add the y's, right? That's how you do it. Well, there's a problem in the textbook. There's a problem in the practice set. It's like practice set number 5. It's like textbook problem, just so you know. 12.2. Number 32 and 33, if you're curious. You're like, what problem am I doing? I'm doing a problem like number 32 and 33 from the textbook, from this section. But I'm also looking at the practice set. This one's like number 5. This is like number 5 in the practice set. How do you add the vectors? But they didn't give you the components. Let me say it again. How do I add vectors? But they didn't give you the components. They like start with a magnitude. So I'm going to go in here. Let me just draw some vectors. I think I'll make this guy like, here, you're negative 6. That's one vector. Here's another one. I'll start it here from the origin. Let's see. You're 4. I just got to pick everyone. I'm going to stop that right there. That's about length. But I do have to give you an angle. So look, I'm giving you the magnitude. I'm just not telling you these components, but I'm going to give you an angle. I'm going to pick one of those neat angles, like 60 or 30 or 45. Should I go with 60? Yeah, I think so. I go with cosine. Try that. Draw this more to scale. There you go, 60 degrees. Length 4. And when this is this magnitude, this is this magnitude. If you want to call that vector A, that's the magnitude, that vector, that's the magnitude for length. But I don't know the components yet. So, when we do have to use a little trigonometry to find the components of this, let's call this right here vector A. So the magnitude of vector A right now is equal to how much?
4.
She said earlier, to add vectors, you need to add the x's and y's. I don't know the x's and y's, so we need a math method to get the x's and y's. All simple trigonometry. And when you see a right triangle in there, let me enlarge that. 60 degrees.
Oh, so adjacent by hypotenuse, that's how you're going to do it? Like
You got it.
Uh,
What's SOHCAHTOA? We're familiar with that, right?
Sine is opposite hypo, cos adjacent hypo.
And this is a 4, right?
Yeah.
Well, what's the cosine of 60?
Root 3 over 2, right?
You know, if I
Or
get this
half.
side right here, I'm gonna call this x and call this what?
Y.
Y. I'm trying to figure out a math formula for x, right? You and I to get, what can I call x? Well, I notice SOHCAHTOA, looking at these three, doesn't cosine deal with these two sides?
Mhm.
So when I'm gonna write this down, isn't the cosine of 60 degrees equal to the x over the 4? So what's x equal to? And let's extend this so we can put something in our notes. How about we say this, that no matter what, every time we do this, over and over and over again, if I'm trying to find the x component of the vector, right, and they give me the angle, then it's just going to be the magnitude multiplied by the cosine of that what? That angle. So this will just be 4 cosine 60 degrees. That's, I'm going to label this. Which component is this? That's the x component. That's this part. She said to add vectors, you got to add the x's and the y's. By the way, in the end, what I'm trying to do is I want us to add these two vectors together. Cool? But you notice, you go, we couldn't do it. You didn't tell me what the x and y. We're going to figure it out from this angle. Trigonometry. Which trig function do you think this one is? Sine. And what I have a feeling you're going to have an easy time remembering that, just from experience. Students seem to easily remember that. It's like, all right, the x component has the cosine, the y component has the sine. Magnitude times cosine, magnitude times the sine of the angle. So that's vector A. I'm going to get my arrow on there. Now what are we adding this to? The other vector. Our goal is to add these two vectors together. Can I erase all that? By the way, since I do that up there, let me put two special right triangles up here. 1, 2, square root of 3. And when it's that 30, 60, 90 triangle, in case we can figure out what these values are. The other guy is the 1, 1 square root of 2. Next class, I'll give you a copy of the trig sheet, which just has this stuff on there. Sometimes you just need a trig refresher. Now, I haven't done calculus since, May. I forgot my trig. All right, that's vector A. Let's call the other one vector B. What's its magnitude? 6. If I put negative, you go, what's going on here? Well, I notice it went 6 in that direction. Well, and when I'm going to write this one way, but I think a lot of you are going to go, why don't you just do this? And when I'm going to follow the code, we already figured it out. I said all I have to do is put the magnitude down. For the x component, I put cosine, and for the y component, I put the sine, right?
Mhm.
I need to know the angle, though.
120.
What's that angle that would start from standard position, start here and go there?
180.
So I'm going to write that. But I think a lot of you are going to laugh and go, you're making it too complicated. But this would work. It's a length of 6, cosine of what? 180. And a length of 6 times a what? Sine of 180. Yeah, but do you all agree, everyone? What's the x component there? It should be negative 6, right? But the y component is what? Can you all visualize that? You're like, what's the x component? You're like, you went 6 in that direction, so it'd be negative 6 for the x component. You go, what's the y component? You go, you didn't go anywhere this way, so the y component of this is what? 0. And sure enough, everyone, the cosine 180 is negative 1. The sine of 180 is what? 0. So while this works every time, when those lines are either totally horizontal or totally vertical, you might be like, wait a minute. I know what this is, right? Like if a vector just went what? Straight up? If a vector goes straight up, the x component's 0, and all you need to know to get the y component is that, right? You don't have to say cosine 90, sine 90, do you? Cool? So now I'm going to go back to this and say, all right, this in a simpler way is just what?
0.
You bet. I'm going to put this here. Let me put in equals again. Now what's vector A? What's 4 times 1/2?
2.
Because cosine of 60, when you see SOHCAHTOA is a half. So 4 times a half is 2. Somebody be like, can I use my TI-84 to do that? Sure. What's 4 times sine of 60? I want to square root 3 over 2. So what would that be?
2 root 3.
Alright. So I'm using those special right triangles just so you can see this. I mean, I could have written this out, but it'd be an irrational number, right? What's vector B again?
Negative 6 and 0.
6 and 0. Aha, now we got it. That one, this is what we're looking for. What's vector A plus vector B? That's a negative what?
Negative 4.
If you want, we can draw it. Where is it? It went how far? 4 this way, and then it went up that way, right? Now I want to add this vector to this vector. Can I take this and slide this, or can I take this and slide that? Does anyone want to visualize it?
Yeah, please.
I could do vector B plus vector A, or I could take this one and slide it up here. You okay if I do that? So let's visualize this vector. Watch, the triangle law. I'm going to take this so I can move it to here, just like we had it before. I'm just going to go here, right here. Where's that yellow shelf? Right here. And now it's here. There it is. There's vector B, and this vector plus this vector should equal what? C, or A plus B, right? Now does that look right? Does that look like it went 4 this way and up that? You know, it's not the best sketch, but a rough sketch. That's what's going on. Now, can you get the magnitude? So some problems on that practice set, they go, what's the magnitude of that? And they call it the resultant vector. What's the magnitude of this resultant vector? And I think we could do this without a calculator. What's 16? Do y'all agree?
Yeah.
If I square a 2 and a square root of 3, 2 squared is 4. What's square root of 3 squared?
3.
4 times 3 is 12? Let me make sure. Is everyone okay with that? I squared the 2, got a 4. I squared the square root of 3, got a 3. 4 times 3 is 12. So what's the actual resultant vector's magnitude? Root of?
28.
There you go. So how long is that? And you're like, man, I could use the law of sines or something, law of cosines to get that. We'll use vectors now. It's like even faster. I know. I know those laws are available. I haven't used them in a while because you can do everything with vectors. Just add them up here, do that. You're like, there it is. I got that length. Now there's something else on problems like this. I'm going to give you another one.
And in vector, do you always have to keep it in the degree format, not in the pi over 3?
That's right. You're going to notice that when in the book, if they ask you to come up with these angles are in degrees. There's other things in this course that are going to be in radians.
Gotcha.
And when, Kirk's cousin stunk up the joint last night, but like if you want to get like the length of one of his passes, it's coming up. We're in 12, it comes up in section 13.3, arc length. But when you do the arc length, we use integrals. You know those limits on the integral? We put, if it's got trig functions, you put it in radians. You put the limits in radians. So you're right, Art, this would be an angle. I mean, we'll keep these in degrees, but there's going to be some things coming up soon where you go in radians. Most of chapter 12, you keep everything in degrees. So a great job at that. I'm just curious, how about this? What if you add 2 vectors together? And this time I'm just going to give you like an A plus B. Making it up. Let's say this was 10, and this part here was 3 root 3. I'm just making it up. Just to give you now, when I gave you the 2 components, I'll erase this. You'll see where I'm going with this in a second. All right. Everyone knows vector A plus vector B. I just drew an image of it. I gave you the 2 components. The x component is at 10. What's the y component?
3.
I thought I would do this based off your question. Everyone, can you help me now figure out that angle? If someone said, find the angle. Another reason I'm writing this, everyone, I noticed the author did this in those same problems. And he also did this. It's also on the problem set. Can you find the angle that the resultant vector That's this guy. It was the resultant of A plus B. That the resultant vector makes with the positive x-axis. Sorry, I want to write this out. I want to be clear, because if I see just angle, you might be like, which angle? That angle? That angle? So I'm going to say, find the angle that that resultant vector right there, vector A plus B, makes with your which axis? The positive x-axis. And you'll see this on the problem set as well, in the textbook as well. Looks like we need some trigonometry. And it looks like we need a calculator too. Right, Owen? Is that a special right triangle? No. Which one do you want to use though?
Tan.
I love it. Why do you want to use tangent?
Opposite or adjacent.
Someone agree? And we're looking for this angle here. That's the opposite, that's the adjacent. TOA, who's got the O and the N? So what we'll do is, and this works every time in these problems, I'm like, theta will always equal, I'm going to write inverse tangent and then write the ratio. Okay? Tangent of theta equals y over x, then inverse tangent of y over x gives me my angle, right? What's the y value? 3 root 3. And what's the x component? 10. And right next to it, I'm just going to put a light y over x, so you can say, oh, angle made with positive x-axis will always be inverse tangent of y over x. Cool. Now, what mode? Check your modes, just want to make sure it's degree, and what's the angle? I don't know, is it?
27.45.
Alright, there it is, on that angle, 27.45 degrees. And just put it roughly. We rounded it. There you go. Boom! Rest of class, 12-3.